Alright, today we're going to talk about the product and the quotient rules and high order derivatives. So I'm in your luxurious library doing my video. I thought two of you would stop by. But let's start with the product rule. The product rule states the derivative of two functions being multiplied together is going to be the derivative of the second function times the first plus the derivative of the first function times the second. I have a little catchy phrase for you. Fishing great gives freight, and every time you hear the 8 sound, that's when you're taking the derivative. So let's try one. Alright, right here I've got two functions. F of x is equal to 3x minus 2x squared, and the quantity 5 plus 4x. So we're going to find h prime of x. So let's do that. H prime of x says fishing great, the first times the derivative of the second. So that's the first times the derivative of the second, which would be just 4. Okay, the 5 is 0 if you remember. Derivative of a constant is 0, plus the second times the derivative of the first. Derivative of the first just seems to be 3 minus 4x by using the product of the power rule. So now we just got to get these two guys together and roll. So we're going to get 12x minus, I guess, 8x squared plus, let's FOIL this out. Alright, remember we're going to FOIL it out, so it's going to be this times that. And after the FOILage, we should get 15 minus 16x squared minus 20x and then plus 12x. I mean, this is the derivative, but we need to make it look a lot better. Okay, let's combine our like terms. Our like terms are right here and right here. Okay, that's negative 24x squared. We need to combine our other like terms, which make it 4x, and plus 15, and voila. This is h prime of x. Nice, nice. Remember, first times derivative of second, second times derivative of first. If you say it like 3 times real fast together, it'll work, no problem. Let's do some more. Here's one that involves the sine of x, your favorite. All right, x times sine of x. Let's do it. No problem. First times the derivative of the second. Well, the derivative of sine is cosine. So first times the derivative of the second plus the second times the derivative of the first. Well, the derivative of the first is 1. So I get as an answer x cosine x plus sine of x. That's it. It's h prime of x. Nice, nice. A little bit of work, but not too shabbily. All right? And I want to do one more. I want to do like, let's do x cosine x plus sine of x. Well, we're going to do this one's going to be a product rule, and this is going to be just a regular old derivative. Makes sense. Let's product rule the first one. All right. The first one's going to be, I think, this is supposed to be, I'm sorry, this is supposed to be h of x. There we go. All right. So we're going to product rule that. First time, it's the second times, did I screw up anywhere? No, I'm good. The first times derivative of second, well, the second is negative sine. Do you see how I did that? First times the derivative of second plus, this is still this one, second times the derivative of first. That's it. Derivative of first is 1. Now I'm going to do the other one in green. I'm going to do this guy in green. And I'm just going to get the derivative of sine is cosine of x. So now my answer would be, let me scroll, would be, let's go with 2 cosine x minus x sine x. And that would be our derivative of this h function. Anybody, any questions? Looking around the library, nobody cares. So there's no questions or caring going on. All right. That's the product rule. This is the quotient rule. Quotient rule is a little trickier. The quotient rule is we have one function over another function. So this is what we do. The bottom gets squared. And it's the bottom times derivative top minus top derivative bottom. You can say that a few times. Bottom squared. Okay, that's on the bottom. It stays on the bottom. And it's the bottom times derivative top, top times derivative bottom. So let's do this one example, and you'll see it in action. All right. So we're going to do the bottom, and we're going to square it. So you're going to get this. Bottom's done. Now it's the bottom. Remember to put your grouping symbols in. You're going to need them. Times the derivative of the top, which is just 5, minus, remember this one's minus, product rule was plus, minus the top times the derivative of the bottom. And derivative of the bottom is 2x. Now remember, that minus is for this whole product. So watch what happens. This minus might be the most erroneous thing that happens. That's going to be where all your errors happen. So it's going to be 5x squared plus 5, and then it's going to be, ready, minus 10x squared plus 4x, all over this thing. We usually don't square the bottom out. We'll combine some like terms. The only like terms we have are here, and my answer to this is going to be negative 5x squared plus 4x plus 5 all over the quantity x squared plus 1 squared. That is y prime. That is my answer, and that is the product rule, folks. It's easy as that. Higher order derivatives. This would be the first derivative, second derivative, third derivative. So if we're taking higher order derivatives, we have to take derivative after derivative after derivative, right? And this is what they look like. After 3, they just start putting numbers in parentheses. That's it. Here it is. Other ways, you always see 2. I haven't seen many 3s, especially on AP exams, but they exist. Let's go. Let's do another one. So we're going to FOIL these first. So now I have 3 of them. You say, how do I do the product rule with 3 of them? Well, guess what? You have to FOIL one of them, or you have to combine one of them. I could have combined these 2 or FOILed those 2. I'm going to FOIL those 2 because they're a little easier. I can do it in my head. All right? So I'm going to get f prime of x. Or, you know what? I'm just going to rewrite it with the FOILed term. I'm not priming nothing yet. Not priming the pump yet. So it's f of x is going to be equal to this first guy. All right, I know I'm looking down. I should be looking at you guys. And then it's going to be times this. Well, that turns out to be x squared. Help me out here. Minus 4x minus 5. I like it. And now we can do our product rule. Actually, if you wanted to, you could multiply them all out and just do power rules. That's also an issue, right? I could multiply them all out, get power rule. I'm going to show you the product rule works too. Here we go. The first, now we're doing the derivative, so we put the prime there, and now it's the first times the derivative of second. Derivative of second is 2x minus 4, and then plus the second times the derivative of the first. Well, the derivative of the first is 9x squared plus 4. Now when all the smoke clears and I FOIL them out and get them all down, this is your answer. There's a lot of algebra being done here. A lot of algebra action being done there. All right. This was some homework problems. We'll talk about the homework later. Okay? I'm not having you do all that at home. All right, let's do trig functions. Let me show you what it's all about to do some trig functions. Let me get my notes going here. I do have notes once in a while. I need them. They're like the security blanket, like this. All right, I'm not having meatloaf tonight. I think tonight, wow, what are we going to have for dinner? I know, I got to think about it. We said we're having something. I forgot. All right, so we have all these trig functions. Nice. Well, I'm going to derive one of them. This is going to be, I'm going to derive this, okay, from scratch. So let's look at y equals secant of x. So it's 1 over cosine. So now I'm going to use the quotient rule to tell me what the derivative of secant would be. So take a look. You're going to be required to do this on a test. So take a look. We have y prime is going to be equal to the bottom squared, cosine squared of x. Okay, square the bottom. If you don't like to put the squared there, it's okay, folks. It's all right. You want to put the squared here, put it there. Okay? So it's going to be the bottom squared, and then remember, it's the bottom times the derivative of the top. The derivative of the top is come on. Sine x. I'm sorry, I got distracted. Now you ready? Plus, that's the belt. See, I'm in between periods. I'm sorry, minus, because we're doing quotient rule, minus the bottom times the derivative of the top. Well, the derivative of 1 is 0. So this guy is gone. And I'm just left with cosine sine over cosine squared. Well, I'm going to cancel one of the cosines. So I'm going to get y prime equals cosine x sine x. Hello there. Over cosine x. And I'll write it like this if you like. Boom. Those are gone. So now we're left with sine over cosine. What do you know is sine over cosine? I think that's the tangent. That's the tangent of x. I think. Let me see if I'm right. I hope I did that right. I think I screwed it up, folks. I definitely screwed it up because I don't know if I can cancel one. That was 0. Oh, I screwed it up. Okay, I screwed that up. Let's continue. All right. So we have the bottom squared, and now we're going to do the bottom times the derivative of the top. So the bottom times the derivative of the top. It's 0 because it's a constant, minus the top times the derivative of that looks like an absolute value sign. I don't want it to look like an absolute value sign. Times the derivative of the bottom, which would be just sine x. And remember, it's the derivative of what it was originally. So I'm going to get, if I'm right, sine x over cosine x times 1 over cosine x. All I did was break them up to show you now what we have is going to be the derivative of tangent x times the, what is it, secant? Secant x. So this is the derivative all the way back here. All the way back here, tangent x secant x. Sorry about that screw up before, but there it is. We derived what it was. How great is that? And we could do many more. Okay, we could do many more, like this one. You should try this one. This is the first one you should try for homework. And you should get something crazy like negative cotangent cosecant x. All right? Make sure you can do that. Going on, here's some special ones. Now, all these up here, you can derive, but it's kind of easier if you memorize them. Just future reference. So we have the tangent, derivative of tangent is secant squared. That's a big one. Derivative of secant is secant tangent. I got that underlined. That one must be big. Or I just was testing my pen out. I don't know. And derivative of cotangent is negative cosecant squared. All these are fair game. Okay? I want to do, I believe, at least one more here. But before I do it, let's see, how many more do I have? This one, and I'm running out of time here. All right, so let me ask you to do this one for number 2 for homework. Let me continue and show you the high order derivatives. Here they are in a nicer table. Before I showed them to you, now they're in a nicer table. So, like I said, 1, 2, 3. We usually don't go on beyond 4, but here they are for you. You can pause it. You can take a look. Nice, whatever.